All right, this is for Algebra 2, Lesson 8, numbers 1 through 10. And before I get started, let me just review here that you need to know, I mean, goodness, this is going to be on your test as well. What is I equal? And I is defined to stand for the square root of -1. So I squared, I just want you to know this without even thinking, I squared is -1. I to the third is -I. And I to the fourth is 1. Okay, so this one I would say is extremely important. You can tell I'm looking through my screen. And of course but these two I would say, make sure you know I to the fourth is a +1, I to the second is a -1. Okay, so number 3. I should have set up here that these were numbers 3 through 10 up here, so I'm skipping 1 and 2. 1 and 2, hopefully you can find the conjugate. Remember, it's exactly the same, you just change the middle sign. But when you multiply these two, what's cool about the conjugate is because you have opposite signs here, your middle terms will cancel. So all you have to do is multiply your first two together, which would give you 25. Notice if you multiply these two together, you get a positive and a negative, which is a -16i squared. But I squared is -1. So I'm going to write out a lot of steps on this first one. Okay, but you can see here that this negative and negative is going to give you a positive. So you would end up with 25 plus 16, which is what? 41? So I think that's kind of cool right there. Okay, try this one again. These are conjugates of one another because they're exactly the same except for the middle sign. Okay, so if you multiply the first two together, you're going to get what? 9x squared. And if you multiply the last two together, you have a positive and a negative, which is negative. And by golly, I hope you know that the square root of 11 times the square root of 11 is just boring 11. So that's all you get. I mean, you guys, you can do this without really showing a lot of work. Okay, now this one's a little harder, okay? You would hope that this is the difference of squares. They're wanting you to just find the factors. That means find two things that multiply together to give you this. And I've been picking up walnuts. My nails are nasty. Okay, so this times this. What right here would give you 4x squared? Well, hopefully that one's easy. 2x times 2x. Right there. Okay? Okay, what's going to give you 3? 3 is not a perfect square. Like 4 is a perfect square, 3 is not. But do you remember up here that the square root of 11 times the square root of 11 is 11? I want you to think about that when you're doing this 3. It would be the square root of 3 times the square root of 3. When you multiply that together, you're going to get boring 3, and your signs need to be different. So this right here would be your factors, because these are the two things that multiply together to give you this. Now, on number 6, it wants you to find x. It says, hey, solve for this. What would give you 0? Do you remember how to do that? Take one of these and set it equal to 0, and you're going to get to where you can do this mentally, okay? So set it equal to 0. So how do you solve this? Move this to the other side. Remember, if it's positive on this side, when you move it to the other side, it's going to become negative, and then just divide both sides by 2. So that you can see x is going to be a negative, the square root of 3 over 2. So obviously, hopefully, when you solve this one, you're going to get a positive, the square root of 3 over 2. So I'm just going to be lazy and write my answer like this. You're going to get two answers, plus or minus, because one time it'll be positive, the square root of 3 over 2, and the another time you'd get negative, the square root of 3 over 2. Okay? Same thing for this one. Gosh, this one's a little harder because now all of a sudden you've got a fraction, but all it wants you to do is find the factors. So let's do that real quick. This one should be easier because the square root of 1 is 1 and the square root of 9 is 3. So I know here I should get 1/3 times 1/3. Okay, I know my signs will be different. I know one's going to be plus and one's going to be minus. But 3 is a lot like this one, okay? You took the square root of 3 times the square root of 3 to get you boring old 3. Same thing here. This is just going to be the square root of 3y. And this one would be the square root of 3y. Notice if you multiply this together, you would get 3y squared. Okay, so these are your factors. And then on number 8, again, it says to solve this. So take one of them, who cares, and let's set it equal to 0, and let's solve it. So I'm going to do that over here. Okay, there it is. Move your 1/3 to the other side. If it's negative on this side, when you move it to the other side, it's going to be positive. So you have this. This one's going to be maybe a little harder because look what happens. I'm going to have to divide both sides by the square root of 3. When I do that, you're going to get this. Okay, it's on the top on this side, so when I move it, it's going to be the opposite. It's going to be on the bottom. But you guys remember, you can have a radical. You can have the square root on the bottom. So what you're going to have to do here is multiply both the top and the bottom. I'm trying to get my marker open here by the square root of 3. Let's see if this one will work. Let's hope so. So if I do that, if I multiply by the square root of 3, my paper is slipping, over the square root of 3, look, 1 times the square root of 3 is the square root of 3. Right here, the square root of 3 times the square root of 3 is just 3. This right here is 3 times 3 is going to give me 9. So, sorry, had to write it like that real quick. So there's one of your solutions, but remember, because they're exactly the same, but your signs are different, one's going to be the positive value and one will be the negative value. So you can be real lazy on that and just write plus or minus, and that will give you your 2 solutions right there. Okay. All right, let's see if I have time on this little video to do numbers 9 and 10, just real quick. Right here, look first of all in 12, over Betty, realize I can write this like this, negative 4 times 3. I'm choosing 4 because 4 is perfect. When you pull that 4 out, first of all, the negative is going to become an I. When you pull the 4 out, it becomes a 2. So when I pull this out, it all of a sudden becomes 2I. I still have my 11. And then that 3 is not perfect, so it has to stay underneath. So look what you've got here. You're going to have 22I square roots of 3 right there. And this one doesn't look like you can do anything but pull the negative out. The negative, when you pull it out, becomes an I, so you're going to have plus 6I square roots of 3. Now these are like terms. They both have i's, and they both are the square root of 3. Therefore, I can combine them. And 22 plus 6 is what, 28? So I should get 28I square roots of 3. You can write it like that, okay? Typically, I will write it 28 square roots of 3I. I like to stick my I out on the end like that, but you do whatever floats your boat. Okay, this is the way I've always seen it, but I noticed the book lets you write it like that sometimes. Okay, last one. Notice here we are multiplying, okay? Here we were adding. Things are done just a little different, but I can still simplify that. This right here is a perfect square. The square root of 64 is 8. Pull that out and it's an I. So look what you have. You have 7I times 8I. 8 times 7 is what? 56I squared. But what's I squared? Negative 1. So I'm going to get negative 56. Because 56 times negative 1, okay, is a negative 56. So there's you the first few problems.